put slows in on the brackets?
What's the question?
I was looking at the text and you were
Alright,
like,
it is recording by the way. So.
so you missed your bus?
No, I had.
Yeah.
I know. Like
Yeah,
they're both more real than
I think so. Alright, here we go. So, how do we figure out this bell ringer?
That's a good
Magic.
It's K.
It's a great question. What is that? What is that thing up there? What's it called?
A function.
A type of function.
A special
Dang it.
A piecewise
A
function.
piecewise function. Very good. So, we need to figure out which graph relates to that piecewise function.
Hey,
It's okay. How'd you figure it out?
I never liked
Ryan.
So first I looked at the straight lines.
Okay.
So I did the middle one first.
You do this one first. So x minus 7. Okay.
Yes. And I saw that H and K fit that.
Why doesn't J?
Okay. H and K fit that. What do you mean by that?
H and K fit
Well,
the.
how do they? What do you mean by they fit that? Like how do you know they fit that? What specifically are you looking for?
The point.
Like what sort of point? Like can you
Open or close?
open or close? Thank you. So we know it's got to end at 1 and 5, right? And they should be open points. So if they don't have that, ends at 1 and 5 with open points, we know that it can't be that piecewise. So this one's got a closed point, it ends at 0. This one's got a closed point at 5. This one's got a closed point and ends at 0 again. So I know it can't be any of those three. Good. What else did you do?
And then I saw H for the first one.
Okay.
It ended at 2 instead of 1.
So H ends at x equals 2 instead of x equals 1. So I know I eliminate all the other 4. Must be K. Good. Process of elimination. Do that. Yeah. So look at the ranges from 1 to 5 with open-ended endpoints. Ends at 1 and then goes left. Well, this one ends at 2. So I know it can't be that one. Very good. That's exactly what you should do. Right? You can plug points in and make sure the graphs line up if you want. Right? Use that process of elimination. Use that skill. Very good. Any questions?
Wait, so what else did you do?
That's all he did.
You just solved the middle one?
He used the endpoints. He knows they got to end at 1 and 5 with open circles. Well, that middle one doesn't have open circles here, or there, but it does there. So then he used the top one. Yes, Tommy?
Question, why are you recording again?
Because Cassie's still not here.
Oh.
And she asked me to, and I'm nice and I do that. It's like if you are ever going to be gone and you know ahead of time, like, hey, Mr. E, can you record the lesson tomorrow? I'd say, yeah, Tommy. Anything for you.
Hey, Mr. E, I'm gonna be gone Friday.
Next Friday?
Yeah.
Well, we're taking midterms, so there's no
Oh.
lesson.
Oh,
All right.
crap.
Homework. Homework. Please check 1. Please check number 1. If you look at it, it's just writing domain. So, number 1, F, G, and M. No denominators, no square roots, so it's just negative infinity to positive infinity, X in the real number set. The H function has a radical. So, I need to take what's under the radical, set it greater than or equal to 0, solve for X. X has to be greater than or equal to 8. So, bracket, 8 to infinity, parentheses.
Oh, yeah, okay, never mind.
Okay?
I forgot that you had to convert the things to greater than or equal to.
Yep. Alright, guys, questions on number 1.
Nope.
Wait. What about? I have a question for letter A.
Okay.
Why does X have to be greater than or equal to A?
Because we have to take what's under the square root, set it greater than or equal to 0. Alright, then we got to solve for X. So we add 8, X is greater than or equal to 8. So, 2, 3, and 4. Check the answers, please. Guys, today's lesson, like I said, it takes a while. I haven't gotten through all the problems in any of my classes. I'm not going to have a ton of time to sit and answer questions today. Alright, so throughout the lessons on the homework, we got to keep moving. Yes, Paige?
Can I fill my water?
Yes, hurry up. Alright, 2, 3, and 4, any questions? right? The operations shouldn't hurt us, right? They shouldn't take us very long. The domain, that's newer stuff, that might take a little bit longer. 5, 6, and 7. Questions on 5, 6, or 7?
Nope.
Right? 6 is tough, right? It's got more than one restriction, so it's going to have more than one union. Jalen, what's your question?
Where did you get all those restrictions?
So if I look at 6, I got to look at where I start and where I end. Well, I have a denominator where I start, but 2x squared plus 5x minus 12, is that easy to figure out what makes that equal 0?
No.
No, so what I would do is I would use the factored version of it. This means the same exact thing as that, but that's factored, right? So if I use the factored two pieces, I can set both of them equal to 0 because of that zero product property, right? One piece equals 0, the whole thing's going to equal 0. So 2x minus 3 cannot equal 0. Solve it. We get x cannot equal 3 halves. X plus 4 cannot equal 0. We get x cannot equal negative 4. Those are my two restrictions. Use this. Use that factored piece. It's way easier than trying to figure it out the other way. And you're going to have to factor it anyway to solve it. Unless you're using quadratic formula, which you're more than welcome to. But any questions, Ryan?
If we just put regular R, will be wrong on the test?
Regular R would be wrong, yes. That's
You
just,
got 7 wrong?
Miss Furman got 7 wrong, yes. I like to throw her under the bus. She knows I throw her under the bus, so it's alright.
Wait, how did she get 7 wrong?
Because she doesn't have the two-stemmed R for the real number set. She's got R. Alright, backside number 9. F, G, and H functions are all negative infinity to positive infinity. Right? There's no restrictions on them. M is a radical, so we got to take what's under the radical, set it greater than or equal to 0. So 5 plus x greater than or equal to 0. Subtract 5 from both sides. X is greater than or equal to negative 5. Questions on 9? How are we doing with the domain?
Good.
Yeah, we're still kind of struggling. We're getting some more practice today, so it's good. Alright, 9, 10, and 11. Check them out. Check it out. Mind your way. Questions on 9, 10, and 11. Jalen.
Why is x greater than or equal to 5? Couldn't it just be greater than?
For which one? This one?
Yeah.
Well, why couldn't it equal negative 5?
Because 5 plus negative 5 is 0.
But I can have a 0 under the square root, right? Square root of 0 is 0. So I can't have a 0 when it's in the denominator. Okay?
Why are there restrictions at all?
Why are there restrictions at all?
Yeah, if it's not, doesn't have anything to do with the denominator, then how's it?
Because I can't have a negative square root. I can't take the square root of a negative number. That gives me an imaginary number. Right? We're dealing with the real number set. No imaginary numbers allowed. We're kicking them to the curb. Kicking them out. Alright. 12, 13, and 14. 13, a little interesting one. The domain. It's not x greater than or equal to negative 5. It's x is greater than negative 5. Why? Sarah.
Because since you have a radical, x is greater than or equal to 5, but since it's in the denominator, x can't equal negative 5.
Perfect, right? Because it's a radical, it's x is greater than or equal to negative 5. But if x equals negative 5, my denominator is going to equal 0. So x can't equal negative 5. Very good. So we get x is greater than negative 5. Awesome. Any questions on those problems? Alright, then, lesson today. We're talking about composition of functions, or function composition, however you want to say it. So, I think we've seen the basics of this in geometry. So it shouldn't be completely new. We'll get some composition of functions. We'll talk about domain a little bit more. We're going to have some fun. Alright, we're going to get through some problems. So, function composition is the applying of one function to another. So we read it as f of g of x, or g of f of x in this case. You'll see it written both of these ways, as well as you'll see it written as like g of f. That's a terrible writing, but you'll see. Right? So, you'll see it written in any of these three ways. They all mean the same thing. G of f of x, g of f of x. Now, My brain works in weird ways. I have to see it written like this. That's the way that makes the most sense to me. So if I get a problem and it's written like that, what do you think I do?
Change it.
Just change it. Change it so you're comfortable. Whichever way you're comfortable with, change it. There's no one saying you can't. Right? Change it to what you're comfortable with. A lot of times you'll see it, if it's written like that, I'm going to change it to that before we go any farther. Right? That's just how my brain works. It's how I need to see it. Alright? So what we're going to do is we're going to take the result of f of x and put it through the g of x function. And that sounds like a bunch of mumbo jumbo right now. Do some examples, be a little bit more helpful. Alright? So, first thing I need to do though, is I need to find the domains for f of x and g of x. So f of x is 2x plus 3. Do I have a denominator? Do I have a radical? So what's my domain? Negative infinity to positive infinity. Real number notation. X is in the real number set. G of x, same thing, no denominator, no radical. Negative infinity, positive infinity. X is in the real number set. So, now here's what we do with that function composition, where we have g of f of x. What we're going to do is we're going to work from the inside out. Whenever we're doing stuff like this, we're working inside out. Alright? So if I look at f of x, what does f of x equal?
2x plus 3.
2x plus 3. So what I'm going to do is I'm going to replace f of x with 2x plus 3. Right? They say they equal each other, so I'm just going to replace it. Now, here's the tricky step where people kind of get lost a little bit. What we're going to do now is I'm going to take anything that's in my parentheses, in this case 2x plus 3, and I'm going to apply it to my g function. Or I'm going to take that, whatever's in the parentheses, and anywhere I see an x in my g function, I'm going to plug in 2x plus 3. So it becomes 2x plus 3 squared. Right? So anything inside the parentheses, into my g function, wherever there's an x. So it becomes 2x plus 3 squared. Does everyone follow me?
See.
Okay, so then all we're going to do, I'm going to FOIL. Right, my favorite F word. 2x plus 3 times 2x plus 3. We get 4x squared plus 12x plus 9. Now I combine my like terms as I was foiling. I assume we're all able to follow that step at this point. So, I'm looking at that. I need to look where I started. Did f or g of x have restrictions?
No.
No. Does my new answer have restrictions?
No.
No. So my domain is negative infinity, positive infinity. X is in the real number set. That wasn't bad, was it?
No.
Alright, let's try another one. F of g of x. Now do it the other way. So, g of x equals x squared. So I'm going to replace it in here. F of x squared. So now what I'm going to do is anywhere in my f function, because that's what I'm dealing with now, anywhere in my f function that I see an x, I'm replacing it with x squared. So 2 times x squared plus 3. Let's do the multiplication. 2x squared plus 3. Can I combine anything else, simplify it at all?
No.
No, so that's my answer. But I also need the domain. Done? Awesome. I will grab one for you. Alright. So, here's the note packet, here's homework 1, and then we're going to take your midterm next week. You got one of these? Awesome. It is actually due, believe it or not, next Wednesday, because I won't be here Thursday. So instead of Thursday, it's due Wednesday. Alright? Okay. So, domain, f or g of x, where I started, do they have restrictions?
No.
No. Does mine end?
No.
No. So negative infinity, positive infinity, x is in the real number set. Awesome. Any questions? Alright, let's keep rolling then. So, domains. Tommy.
Why do we keep using the real number set if it's not going to be on the test?
Because we want you to be able to do both notations. Right? We require you to do interval notation, so I believe that's what FST and pre-calc use, and that's what we want you to get comfortable with. But we want you to know both notations. Okay? So, f of x, g of x, h of x. We need the domains for all of them. Well, does this one have denominator or radical? No, so negative infinity, positive infinity, real number set. X is in the real number set. Then, g of x, same thing, no denominator, no radical. So negative infinity to positive infinity, x is in the real number set. Awesome. Same thing with the last one, no denominators, no radicals. We go from negative infinity to positive infinity for interval notation. X is in the real number set for real number notation. Yes? Yes, bring your pencil.
Oh, I don't have a pencil.
Oh, well, then borrow someone else's. Right here, I'll grab a pen. Alright, first one. It says f of g of x. So, gotta figure out what g of x equals. You filled out?
Oh, no, because I don't have a pencil.
No, you filled out. So, how are you taking notes?
In my mind.
So maybe we should have asked for a pencil. So, f of g of x. So g of x equals x minus 4. So I'm going to make it f of x minus 4. And then anywhere in my f function that I see an x, I'm going to replace it with x minus 4. So, this turns into x minus 4 squared minus 5 times x minus 4. Is it plus 3? Plus 3. Awesome. So, do the algebra, right? Do the work. FOIL at the first part. X squared minus 8x plus 16 minus 5x plus 20 plus 3. We all follow me so far?
Yeah.
Awesome. So, keep going. Combine your like terms. X squared minus 8x. Excuse me, minus 13x. Plus 39. That's as far as I can simplify that. So, look at where we started. F or g of x, do they have restrictions? No. Does my n have restrictions? No, so it's just negative infinity to positive infinity. X is in the real number set. Awesome. Try the next one. G of x. So, g of x equals x minus 4. So I'm going to plug it in. So now I get g of x minus 4. So anywhere in my g function I see an x, I'm replacing with x minus 4. I get x minus 4 minus 4. Right? What does that turn into?
X minus 8.
X minus 8. So same thing. G, my original g function does not have any restrictions. My endpoint does not have any restrictions, so negative infinity, positive infinity. X is in the real number set. Awesome. Last one for this page here. H of f of x. So, f of x equals x squared minus 5x plus 3. Yeah. Yep. So, anywhere in my h function I see an x, I'm replacing it with x squared minus 5x plus 3. So I get 5 times x squared minus 5x plus 3 plus 1. So do my algebra. All I'm going to do is distribute my 5 and then combine my like terms. 5x squared minus 25x plus 15 plus 1. So then combine 15 and 1. And then my domain, h and f of x, both do not have restrictions to start with. My endpoint does not have restrictions, so negative infinity to positive infinity. X is in the real number set. Any questions? Alright, do a couple more problems like this. But first we need to find the domains. And I get it, it's a little repetitive, right? But we want the practice. We want to make sure we know how to do it.
Can we just start writing them in just the form that we need on the test?
If you would like to. Alright, f, g, and h functions. Do any of them have a denominator? Do any of them have a radical? No. These first three functions, none of them have a denominator. So, I'm going to go negative infinity to positive infinity. X is in the real number set. And I'm not going to waste my time writing them all out. So I want to make sure I save as much time so you guys get some homework. Alright. K of x. Does it have a denominator?
Yes.
Does it have a radical?
No.
No. It just got the denominator, right? So I need to figure out what's going to make that equal 0. Negative 2. So I know x cannot equal negative 2. So when I go and write it in real number notation, x is in the real number set, comma, x cannot equal negative 2. Then my interval notation, I know it can be any number from negative infinity to negative 2, but not negative 2. Union, negative 2 to infinity, right? Any of those numbers work besides negative 2 is what I'm saying.
So if you don't have the infinity, it's wrong.
If you don't have the infinity, it's wrong. Alright, last one, up there. M of x equals square root of 2 plus x. It's got a radical, right? How do I find a domain for that then?
You put it greater than 0.
So take
Or
what's
equal
under the
to.
radical, 2 plus x. Set it greater than or equal to 0 and solve for x. So in this case we subtract 2. X greater than or equal to negative 2. Right? So I'm going to write it out. Real number notation, x is in the real number set. X greater than or equal to negative 2. Then, interval notation. Oops, I don't want negative infinity. Right? I know it's from negative 2 and up, so my farthest left number is going to be negative 2. I know it can equal negative 2, so I'm putting a bracket around it. Right? Then it's going to infinity.
If you're putting a bracket around it, why does it not say Arizona wins?
God, you're funny, Tommy.
Can you like leave? The door is right there, Tommy.
Alright, guys. Guys and gals. The first one. Insert in that funky notation, right? M of g. So I'm going to rewrite it. M of g of x. Right? I said my brain works in weird ways. I want to rewrite it. That's what makes most sense to me. So the first one is always the outside one. M of g of x. Hi, do you need a pencil?
Yeah.
That yellow box right up there? It's got a bunch of them in it. You can have it.
What happened to
No,
tying the
not the entire box. You can have a pencil.
What happened to tying the pencil around his neck?
I'm going to. I did that for another student I had earlier this year.
Wait, you did?
Yeah, I made him a pencil necklace so he didn't lose his pencil.
You
He
never
still lost it, but...
You threatened Jared, but you never got it.
Alright, we're going to get him
You
one.
gave me the pencil.
Alright, so m of g of x. So g of x equals 4x. So it becomes m of 4x. Well, m of x equals square root of 2 plus x. So anywhere I see an x, I'm going to replace it with 4x. So it becomes square root of 2 plus 4x. Can I simplify that? No, I can't.
No.
So that's my answer right there. So I'm looking for restrictions now. My restrictions from the start, did m or g of x have a restriction?
The M.
The m did, what was it?
It can have x is greater or equal to negative.
X is greater than or equal to negative 2. So that's one of my restrictions. This is my endpoint. Is that going to have a restriction?
Yes.
Yeah, it's a radical, right? So I need to take what's underneath it. 2 plus 4x. Set it greater than or equal to 0 and solve for x. So subtract 2. 4x greater than or equal to negative 2. Divide by 4. We get x is greater than or equal to negative 1/2. Now I have two inequalities for my restrictions. I'm not going to list both of them. That wouldn't make much sense. What I need to do is figure out which inequality satisfies both of them all the time. Now some people are going to be able to just look at it and say, hey, it's that one. Other people, draw a number line. Right? Let's draw one out. Draw a number line. 0, 1, 2, -1, -2. And then put the two inequalities on it. I know x has to be greater than or equal to -2. We're going to skip the next one, so if you want to put your number line over there, you can. Alright, I'm just moving it down here for right now. So, x is greater than or equal to -2. So -2 filled in, greater than or equal to, it goes to the right. X is greater than or equal to -1/2. So -1/2, greater than or equal to. So I need to figure out which of those inequalities satisfies both all the time, no matter what number I pick. In other words, which one is always in the overlap section? -1/2, right? It's this one. The one that starts here, it's always in that overlap piece. If I pick -1, that satisfies this first inequality, but it doesn't satisfy the second one. So I know that can't be it. I can't have that. It's got to satisfy both. So I know it's x greater than or equal to -1/2. That's the restriction I'm going to use for my domain. Alright, so I'm going to write my domains. I get bracket -1/2 to infinity. And then my real number notation, x is in, the real number set. Greater than or equal to -1/2. Alright? Yes, Sarah?
How does it, like, the -2 not satisfy if it's, like, technically going through, like, the -1/2?
Okay, so if I have -2, right? I plug it in. -2 greater than or equal to -2. That's true, correct? Is -2 greater than or equal to -1/2? No. So it doesn't satisfy that restriction then. So I know that one I can't use.
Okay.
Right? If you want to think of it that way, take the biggest number on each of these that satisfies them and see if it works in the other one. Right? If it does, that's the one you want to use. Okay? I should say smallest number. But alright, like I said, we're skipping the next one. I think you guys can figure that one out on your own. Plus the notes are on School G. No, we're going to do this one. This is a great problem. So, right, I'm going to rewrite it. That's not what I want to write. K of f of x. K of f of x. Alright? So I rewrote it. F of x equals 2x squared minus 3. So k of 2x squared minus 3. So anywhere in my k function I see an x, I'm replacing it. So I get 1 over 2x squared minus 3 minus 1 plus 2. Wow. It's been a long day, right? So, it becomes 1 over 2x squared minus 1. See, that's a simple mistake. It's a little early. Right? -3 plus 2 is -1. So that's how my denominator changes. I just did the algebra. We all follow that? Then, domain, I need restrictions. Did K or F have a restriction?
K did.
K did. What was it?
X cannot equal -2.
X cannot equal -2. So I know that's one of them. Jalen, do you have a question?
No.
Okay. Then, my answer is going to have restrictions too. Right? It's a denominator. It's got a denominator. So I need to take that, 2x squared minus 1. I got to say it can't equal 0, right? I want to know what will make it equal 0. So I can say it can't equal that. So I'm going to do the algebra. Add 1. 2x squared cannot equal 1. Divided by 2. X squared cannot equal 1/2. So, the what? The square root. So square root both sides. We get x cannot equal positive and negative square root of 1/2, right? Positive and negative. So I have how many restrictions now?
It's the square root.
3 technically.
Oh,
Where did the
Right?
other two?
I have x equals -2. That cannot be 1. X cannot equal positive square root of 1/2, and x cannot equal negative square root of 1/2. So when I go to write my domain, I'm going to have x's in the real number set. X cannot equal negative 2. X cannot equal positive negative square root of 1/2. If you want to write them out as separately, that's fine as well. Yes, sir.
If you didn't square root the 1/2 yet, why is it positive and negative?
So because positive square root of 1/2, if I plug that into x squared, it becomes 1/2, right? Negative square root of 1/2, I plug that into x squared, it still becomes 1/2. Right? So even though I didn't actually take the square root, because it's going to be an ugly decimal and I don't want to deal with that, so I'm leaving it under the square root, it's still positive negative. Okay? Alright, then, interval notation. It's going to be a pretty long one. Alright, so working left to right, smallest number to biggest number. Negative infinity, 2. Negative 2 is my next smallest. Union, negative 2, 2. Negative square root of 1/2. Union, negative square root of 1/2 to positive square root of 1/2. And then lastly, union, square root of 1/2 to infinity.
I don't have enough space to write that.
Just go underneath it. Right? I understand it's a lot to write on there. If you can't fit it all in one straight line, just go underneath it. Right? Keep working left to right though. Any questions on that? Right? There's a lot of unions there. Yes, Paige?
How come you don't have to decide between x can equal negative 2 and x can equal positive negative square root of 1/2?
Because those are just, we're just talking about one number. With the inequalities, it's like a whole number set. Right? No matter if I have x equals negative 2, that has no bearing on if it equals square root of 1/2. If I have like greater than negative 2, that has bearing on greater than or equal to negative 1/2. So with inequalities, we need to choose. Okay? Is that your question?
Yeah.
Awesome. Any other questions? Alright, we need to do maybe 2 of the next page. Quick, 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 quick.
No, not just one.
They're really easy, I promise. I promise.
Okay.
I promise.
Then one.
Why are these ones different?
They have a number.
They have a number instead of x, right? So that means we're not going to have to find the domain. Because we're plugging numbers in, we should get a number answer out, a real number answer. So what this means is, same thing, we're working inside out. Find g of 0 first. So g of 0 equals, so 0 plugs in for x. 4 times 0 is?
0.
0. So then what I'm going to do is I'm replacing g of 0 with 0. So I get, instead of f of g of 0, I get f of 0. So I'll plug it in. 2 times 0 squared minus 3. Well, that becomes 0 minus 3
Negative.
equals negative 3. Awesome. One more quick one. One more. Yes. So, I'm going to rewrite it. G of 2. So, g of 2. Right, I want to find that inside piece first. So I get 4 times 2 is 8. So I plug that in for g of 2. G of 8 equals 4 times 8 equals 32. So, like I said, real numbers, we don't need a real number answer. Alright? Or we do need a real number answer, excuse me. We don't need to find the domain.